Good day, everyone. We are the Group 2 from ME 3112. We are here to present our final project in ME Laboratory entitled Fuel and Lubricants, Determining the Viscosity of Engine Oil and Glycerol using Redwood Viscometer. The presenters in this project are Engineer Kim Micaela ATIENZA, Engineer RIZZA BALITA, Engineer JANINE CARAAN, Engineer Ivan Ryan IYAS, and Engineer JERIC UMALI. So next, please. And to discuss the theory of this report, here is Engineer Umali.
So before we discuss the main purpose of this presentation, let us first discuss the theory behind the lab experiment. So viscosity is a fluid property that causes a layer of fluid to resist flow over another layer of fluid. The resistance of a fluid to shearing loads is determined by its viscosity. It is a measurement of the internal fluid friction that produces low resistance. When two layers of fluid move one over the other at a distance of dy, the difference in their viscosity U and U plus du tends to show overall flow, because viscosity is inversely related to temperature. Dynamic viscosity, defined as the shear stress required to produce unit rate of shear strain, and kinematic viscosity, on the other hand, is defined as the ratio of dynamic viscosity to density of the fluid. So based in according to the Newton's law of viscosity, shear stress is directly proportional to rate of shear strain, which is represented by du over dy. Therefore, shear stress is equals to mu multiplied by du over dy. Kinematic viscosity is represented by mu equals shear stress over du over dy, where mu is equals to the coefficient of dynamic viscosity and du over dy is equals to the velocity gradient or rate of shear strain. So the objectives of this laboratory experiment is first to determine the kinematic viscosity of given fluid at different temperature using Redwood Viscometer. The second objective is to investigate the impacts of temperature on the thickness of different liquids. The third objective is to know how Redwood Viscometer decides the consistency of the liquid. In order to perform these laboratory experiments, here are the needed materials. For the tools and equipment, we have Redwood Viscometer, receiving flask, which is 50 ml, thermometer, stopwatch or timer. For the sample liquid, we have engine oil and glycerol.
Here are the steps to be followed. First, click on the drop-down list to select fluid. Second, click on the drop-down list to select temperature. Third, after selecting the fluid and temperature, click on the lift button. The flow of fluid will start. Fourth, observe the rise in level of fluid in the container and click the stop button when the fluid reaches the 50 cc mark. Fifth, now click on the reset button to reset the setup. 6. Again, select the next temperature and repeat the procedure for all remaining temperatures. 7. After performing the same procedure for all the readings, select the next fluid from the drop-down menu. Next, repeat the procedure for the selected fluid and various temperatures. Observe the variation in kinematic viscosity with change in temperature. Next, click on the plot button to plot the comparative graph for both fluids. And the last one is to compare the graph between kinematic viscosity versus temperature.
So the data gathered is at the 55 temperature. Time record is 525 seconds with a viscosity of 1.29 centistokes. 60-degree temperature is recorded. The time recorded is 325 seconds with viscosity of 0.80 centistokes. At 65-degree temperature, we have 250 seconds and 0.61 centistokes. At 70-degree temperature, we have 135 seconds and 0.32 centistokes. And lastly, at the 75 degree of the temperature, we have 85 seconds and 0.2 centistokes. So this table shows the data gathered based on the virtual experiments and upon the observation and the evidence of the data. As the temperature increases, the time and the viscosity decreases. So with this, we can conclude that temperature affects the viscosity of the fluid. As the higher the temperature, the engine oil becomes less viscous. So next.
Okay, for the result in the findings, at the solution for engine oil, we have the general formula of kinematic viscosity times equals to viscometer constant that have a constant of 2.47 times 10 raised to negative 3 minus to the coefficient of kinetic energy that is 0.50 times to the time. For the simulation one, we have, when substituting to the formula, we got a final result of 1.30 centistroke. Okay, for the simulation 2 of the engine oil, in substituting to the formula at 60 degree in 330 seconds, we get the final answer of 0.80 centistoke. For the 65 degree at 235 seconds, in substituting to the formula, we get a final answer of 0.62 centistoke. For the simulation number 4, at 70 degrees Celsius in 135 seconds, in substituting to the general formula, we got a final score of 0.33 centistone. For the last simulation for engine oil, in substituting to the general formula at 75 degree for 83 seconds, we got a final score of 0.20 centistone.
So let's move forward for the data gathered for the glycerol. So at 55 degree of the temperature, the time recorded is 468 seconds with a viscosity of 1.15 centistokes. At 60 degree temperature, we have 330 seconds and 0.81 centistokes. At 65 degree, we have 235 seconds and 0.57 centistokes. At 70 degree, we have 118 seconds and 0.28 centistokes. And last, at the 75 degree, we have 81 seconds with a viscosity of 0.18 centistokes. So this table shows the data gathered, again based on the virtual experiments, and upon the observation and the evidence of the data, the temperature increases, the time and the viscosity decreases also. Thus, we can conclude, just like in the other one, that temperature affects the viscosity of the fluid. As the higher the temperature, the glycerol become less viscous.
So here are the calculations for each simulation using glycerol. So at 55 degrees with 468 seconds as time of flow, we have the kinematic viscosity as 1.15, 48, 91, 624 centistoke or approximately 1.15 centistoke. For the second simulation at 60 degrees with 330 seconds as time of flow, we have 0.81, 35, 84, 84, 85 centistoke or approximately 0.81 centistoke. For the third simulation, at 65 degrees and 235 seconds as time of flow, we have kinematic viscosity of 0.57, 83, 22, 34, 04 centistoke or approximately 0.58 centistoke. For the fourth one, at 70 degrees, we have 118 seconds as time of flow, and the calculated kinematic viscosity is equal to 0.2872 227119 centistoke, or approximately 0.29 centistoke. And for the fifth simulation, at 75 degrees and 81 seconds as time of flow, the resulting kinematic viscosity is equal to 0.1938971605 centistoke, or approximately 0.19 centistoke.
So in comparison, we can see in the graph that the blue line represents the engine oil and the red line represents the glycerol. So the graph shows the comparison of the kinematic viscosity of the engine oil and glycerol with respect to time evaluated through the Redwood Viscometer. And next. So in summary, we can see that the thickness level decreases as the time of stream decreases, demonstrating that they corresponded to one another. Because the viscometer consistency is dictated by the device, temperature barely changes its qualities, that the attributes are close to one another, and can be said that the thickness, when motor oil is used, isn't dependent on the temperature of the fluid used in performing the investigation. The consistency of fluid decreases as high tensions increase. So for the safety reminders, first, we need to know the locations of laboratory safety showers, eye wash stations, and fire extinguishers. The safety equipment may be located in the hallway near the laboratory entrance. Second, know emergency exit routes. Third, avoid skin and eye contact with all chemicals. Third, minimize all chemical exposures. And fifth, no horseplay will be tolerated. And sixth, assume that all chemicals of unknown toxicity are highly toxic. And last, post warning signs when unusual hazardous materials, hazardous equipment, or other special conditions are present. So that's all, and thank you.